Hi guys. Okay, first lesson of this week is all about writing the equations of conics. So given certain pieces of information about a conic section, just write the equations. So let's go back really quickly to all of the equations for all four of our conics here. Being familiar with these equations is going to be really helpful as we go through and finish this assignment. So these are the equations for shifted conics. That means the centers are not necessarily at the origin, but these are always the ones that are good to use. If we have something centered at the origin, or a parabola with its vertex at the origin, we can always just replace h and k with 0. All right, so the first example today looks like this. We have a circle centered at the origin whose radius is 9 units long. So standard equation for a circle centered at the origin is going to look like this. X squared over a squared plus y squared over a squared. Again, remember that if we have a circle, the denominators are always going to be the same. All right, let's fill in what we know then. What we know is that the radius is 9 units long. The radius then is that value a. So our final answer is going to look like this. X squared over 9 squared plus y squared over 9 squared is equal to 1. We always want 1 on the right-hand side. That is magnification form. That's going to be how we get all that information necessary for graphing later on, especially when we're looking at things that are like ellipses and hyperbolas. Okay, example number 2 here. We've got a parabola which opens to the right. It has its vertex at -2, 0, and is wider than a standard shaped parabola by a factor of 2/3. So before I do anything, think about the equation for a parabola that opens to the right. A parabola that opens to the right has the value of y being squared. So that standard equation is going to look something like this. X minus h is equal to y minus k squared, and then don't forget the stretch goes in front there. Now, what do we have? Well, I know h and k are -2 and 0. When we say that the standard shape is wider by a factor of 2/3, that becomes the a value. That's our stretch. So fill in what we know. I know h is -2. This becomes x plus 2 is equal to our stretch 2/3 y minus 0 squared. Now, don't leave it like that. That is not simplified with that y minus 0 sitting there. I am going to write the final answer as x plus 2 is equal to 2/3 y squared. Okay, that is the final answer. You could move the 2 to the right if you'd like. Doesn't really matter. All right, number 3, an ellipse centered at 0, 5, whose vertices are on the y-axis. The minor axis is 4 units long, and the major axis is 12 units long. So here's what I like to do. When I have ellipses and things like that, especially when the centers are not 0, 0, I like to kind of sketch what's going on so I can kind of get a better idea of what's happening. So if I sketch an ellipse with a center at 0, 5, let's say that's 0, 5, we're told that the minor axis is 4 units long, which means this. B, the variable in the equation for an ellipse, is half the length of the minor axis. So B is 2, and the major axis is 12 units long. That means A, the number under the denominator as well, is 6. A is always half the length of the major axis. So let's figure out where A and B belong, and then we can talk about that standard equation for an ellipse. Now, we're told that the vertices are on the y-axis. This is kind of the last clue here. The vertices are on the y-axis. That means that the end points of the longer side of the ellipse lie on the y-axis. So the end points are somewhere on the y-axis. Our ellipse is going to be an ellipse that is taller more than wide. Right? So it's tall and skinny when the vertices are on the y-axis. Okay, what else do we know? Well, we're told the minor axis is 4 units long. That means from the center, we went 2 right and 2 left. And then we're told that the major axis was 12 units long. That means we went up 6 and down 6. To get to those vertices. All right, so let me write this in. This is the major axis. and this is the minor axis. All right, whichever one is shorter is the minor axis. Sorry, that's a little messy. Okay, so a standard ellipse that is taller and skinnier is gonna have this equation: x minus h squared over b squared plus y minus k squared over a squared is equal to 1. A always goes under the term that represents the major axis. The major axis is along the y-axis. So a, the variable a, which represents half the length of the major axis, will go under the y value. If this ellipse was wider, then a would go under the x value. Now we fill in what we know. I know that the center is 0, 5. So this is x minus 0 squared, y minus 5 squared. And then we fill in the rest. So the minor axis was 4 units long. That meant that B is 2. The major axis is 12 units long. That means that A is 6. It's just half those lengths. That is our final answer. Sorry, that is not our final answer. That is unsimplified. X squared over 2 squared plus y minus 5 squared over 6 squared equals 1. That is our final answer. Again, always want the right-hand side to be 1. Just got to happen. Okay, make it magnification form. That's how we get those values of A and B that help us find the lengths of the major and minor axes. All right, the example here is going to require us to use information about hyperbolas. So there's 2 more vocabulary words that we're going to add to our information here before we can get started. So there are 2 options for a hyperbola. An option can be that a hyperbola opens left and right. If a hyperbola opens left and right, I like to say it has an X shape, kind of, which means that the X term is the positive term. When we have hyperbolas, that open up and down, a hyperbola that opens up and down creates a y. That means that the y term is the positive term. That's how I remember what is positive and what is negative. Up to you guys. You got to be able to remember which one goes with which. Okay, one more thing to note about the equation of a hyperbola. The value of A always, always, always belongs with the positive term. So whichever way our hyperbola is facing, A is going to be the denominator of the positive term, or A squared technically is the denominator of the positive term. All right, 2 more really important things then to talk about. We have this vocabulary word called the transverse axis. The transverse axis of a hyperbola is the axis that connects the 2 vertices. So whether we're facing left, right, up, or down, the transverse axis always connects the 2 vertices. Now, one really, really important thing about the transverse axis is the length. The length is 2 times A, where A comes from the denominator of the positive term in the equation for a hyperbola. The length is 2A. So from wherever the center is, we go left and right A to get to the 2 vertices, or up and down A to get to the 2 vertices. So the transverse axis has a length that is 2A. All right, a little bit more complicated is this thing we call the conjugate axis. Now here's what happens. The conjugate axis kind of just like lies out there. Something like that. It runs perpendicular and straight down the middle of the transverse axis. Okay, so it kind of just sits there in outer space. We don't graph it. But something really important about that is the length of the conjugate axis is always 2 times b. Okay, b comes from the denominator of the negative term. We've got the following information. A hyperbola is centered at 3, -4. So right away, I know that 3 and -4 are the h and k values of our equation. We're told we have x-intercepts. Okay, so if we think about it, a hyperbola has x-intercepts when it's facing this way. When it's opening left and right, we have x-intercepts. If we had a parabola facing up and down, we might not necessarily touch the x-axis. So I know that our hyperbola is shaped opening left and right. That means the x term is positive. Okay, that is going to make a note there. We are told that the transverse axis has a length of 16 units. Now we know this. The transverse axis is equal to 2 times a. So a here is 8. The number sitting under the positive term is 8. The last thing we're told are the asymptotes have slopes of plus and minus 3/4. So we'll talk about that in a minute, what that means and how we fill things out. Okay, so let's start with our standard hyperbola that opens left and right. X minus h squared over a squared minus y minus k squared over b squared is equal to 1. Let's fill in what we know. I know that the center is 3, -4. So this is x minus 3 squared. I also know that a is 8, so we're going to put that over 8 squared minus y plus 4 squared over b squared. Don't know what b is yet. We were not given anything about the conjugate axis, so I can't figure out what the value of b is. That last piece then, the asymptotes, are going to be how we find that last piece of information. So if we're told that the slopes are 3/4 and -3/4, what do we know about the slopes of a hyperbola? Well, the slopes of a hyperbola, the asymptotes of a hyperbola, always follow change in y over change in x. So the number under y is b. We don't know what it is. I'm just going to write b. The number under x is 8. That is equal to 3/4 because that's the slope. We're just going to take the positive one because we know that the slopes are both positive and negative. Okay, use this, solve for b, cross multiply. 4b is equal to 24. That means b is equal to 6. All right, I'm just going to go back in, erase that value of b, get 6, box our final answer. Okay, very last thing then, what are the equations of the asymptotes of this hyperbola in slope-intercept form? That's really, really important if I'm grading your homework. If you don't have it in the right form, you're not going to get the full points for that. So we are told 2 things. The slopes are plus and minus 3/4. Okay, what do we also know? We also know that they go through the center, and the center is 3, -4. So this becomes an algebra problem where you're writing the equation of a line that has a slope and a point. So let's use point slope form. Y minus y1 is equal to m times x minus x1. And let's plug in what we know. All right, first slope. Y minus -4 is equal to 3/4 x minus 3. I'm going to simplify this. Y is equal to 3/4 x. And then that is going to be minus 25/4. I am going to simplify that in my head. All right, other one. So our other slope is -3/4. So y minus -4 is equal to -3/4 x minus 3. Again, I'm going to simplify this in my head. This is -3/4 x minus 7/4 when I move everything over and distribute. All right, that is how we write the equations of conic sections given the information that we've got. Your homework then is to finish the problems on the back. You can do that on a separate piece of paper, or you can print out the handout and then take a picture of that.